And then are you ready to go? So if Ian's planning to
I guess I'm going.
Like, why don't we get started? We're very excited about today's panel on AI in research workflow, or AI workflow in research. Take your pick. Maybe we should ask AI which works better. So it is just lovely to see you all here today. Ram and I are super excited about this panel. So we originally had 3 wonderful panelists, and now we have 2 wonderful panelists because Gilbert G is stuck around Irvine with a flat tire and is very disappointed not to be here with us today. But I do think that this is a topic that is, has the potential to generate a lot of discussion and thoughts and questions and comments. And so, we'll have more time for that, which I think will be great. So our current plan, our 2 panelists, we have Mark Handcock, a distinguished professor from statistics and data science, and Ian Lundberg, assistant professor from sociology. We're so grateful to both of you for being able to come and talk on this important topic that is on our minds in such a major way pretty much every day these days. So rather than have me go on, I'm going to turn it over to our panelists. Our plan is to have the panelists kind of go through their talk. Feel free to do talks. Feel free to ask clarification questions, but please jot down your thoughts and questions so we can really get into it after our panelists are done. So thank you, everyone, and I'll turn the floor over to Aaron.
It's very good to be here today. There's a lot that's been said about AI over time, and there's certainly a lot that could be said, and I think there's a lot that needs to be said. What I've done is I've put together some what I call bullet points which represent positions without necessarily providing a lot of evidence for them. So the purpose of the bullet points is to prompt or lead to discussion rather than prove things. Let me start here. Sure. Whoa.
Let me grab. Unless anyone else who's spoken recently. Does anyone know how to do?
Where's AI when you need it?
Busy fixing that flat tire.
Claude, what to do?
Very well.
I had to click on the screen, so we don't need AI. That's the end of my talk. Thank you. All right, we're going ahead. So firstly, I just want to make some general points. I think it's really important to frame the general discussion. So a number of different points here. You only need to read the things in bold just to be sure. There's a lot of information here. But for me, a really important point is AI is an emergent technology. That is, it was defined by looking at the very lower level, starting at the bottom end, as distinct from a lot of software systems that we define define them from the top down. We define what characteristics it has. We encode those characteristics in software and move forward from that point. AI is based on the hope that if we just put some very low rules in and provided a platform to represent structure that does something useful. And the answer to that for a long time was no, and then suddenly it was yes, and that's the big change. So it's emerged very quickly, but more importantly, it's a strange technology because it's very hard to ensure that it has properties that we care about that are useful to people. We hope it has those properties without being able to ensure it. The second thing I think is really important is the technology evolving extremely rapidly. When I say extremely rapidly, the changes even in the last 6 months have been substantial, and the changes probably in the next 6 months will be very large also. And for the foreseeable future, being years, I would expect it to improve dramatically over that period of time. So any discussion about it should take that fact into account. Things that were true a year ago are no longer true. Other things very important, that the effects of AI are going to differ a lot by discipline. My discipline, statistics, is extremely rule-based. maybe not as rule-based as math, but very close to that, and computer science as well. When you write code, the compiler has no sense of humor at all. Make a mistake, doesn't work, right? So for disciplines that are rule-based, AI has already had a dramatic impact on it. So I can speak from a little bit out in front of general demography because of that reason. But it's very important that the impact on, say, my discipline and the impact on, let's say, the humanities are going to be radically different, and their experience is going to be radically different. So I speak from my own perspective there. The last one, and I think we sort of know this, but it's important to bring forward, is that we read a lot about AI through the full spectrum, but a lot of it is driven by commercial concerns. It's not coming out of universities, it's coming out of commercial concerns who see this as an incredibly important and also lucrative area to be in. So there's a lot of hype coming out of the various firms. They're extremely proud of themselves, actually justifiably, but it's important to note that we can't take at face value all of this. It's not coming out of a scientific interest, it's coming out of a commercial interest. Not that that's a bad thing, but it's worth noting the different focus there. The last one I'll say about this is the rate of change here of the innovations occurring extremely rapidly. I'm drawn back to when the internet was first formed, and people remember things like Gopher. Does anyone here remember Gopher?
Oh,
right. Yeah, it's coming back. Yeah, no more Gopher. But what's happened over time is the amount of information, as we all know, the amount of information on the web has increased dramatically. So even if we didn't have AI and we just had Google search, it would have an enormous impact, enormously changed workflows now compared to what it would have been in the 1990s. It's worth noting how that's changed over the last 30 years. AI is happening over 1 or 2 years rather than 30 years. So that impact on us, our culture, our research, is going to be much more rapid now for that reason. All right, so a view from the mathematical sciences. Number one, AI is a tool. We see it as a tool. We don't see it in sort of more abstract sense. We don't see it in any more philosophical sense. It's just a very powerful tool, as computing was a tool, as LaTeX was a tool, as it changed things because it's a very powerful technology. It excels at computation. It shouldn't be as surprising, but if you have any task which involves either the analysis of information, the finding of structure in it, does an incredibly good job. Coding, it's fantastic at. Simple math or math up to a PhD level, extremely good at. Beyond that, it struggles, but as long as it's a rule-based task, it tends to do extremely well. Formal verification. What I mean by that is that it will come up with solutions to things, such as a proof of a theorem or some code that's supposed to do some task. So since it's very good at doing those things, our role then becomes to verify that what is produced is actually correct. So it's a natural rebalancing given that component to it. So a lot of what we do now has moved from let's try to prove something, let's write 100 lines of code to do a certain task, than to verify that the solutions given to us are in fact valid. Last one here, well, not last one, but this one here, understanding remains a human goal. And what I mean by that slogan is that there's a lot of discussion about how we can understand the output or bring into focus the output of AI models. And the word understanding comes up a lot. It's worth noting because of the construction of the AI systems, they don't have a notion of understanding in them. They're prediction engines. As a result, when we think about understanding, it has to come from the human perspective on it, which is a very different thing. And that hasn't really been defined very well. So we must recognize AIs are not going to help us with understanding. That's a task that humans are going to have to take on. And the last one, this is, I think, quite important, and only really in the last 6 months or so, the importance of judgment. Now, what I mean by judgment there in a scientific setting is AI can take and do very, very well a very broad array of tasks, data analysis, specification of problems, and all of those things. So what falls to humans and what it doesn't do very well is judging what are important questions or judging what an appropriate broad way to attack a problem actually is. So judgment becomes much more of a focus because the other things become less so. So that's sort of where the mathematical sciences are. Now, I wanted now to talk about what I call narrative scenarios. So these are neither true nor false, but the ways to try to understand how to think about AI and how it's going to impact our life. So the chess analogy, which probably everyone here knows, but I'll just briefly say. So we remember chess computers back in the day weren't very good. Then they got pretty good. Then they got comparable to very good players. And then they beat the best player in the world. And then they're dramatically better than the best player in the world. Now, what's happened to chess, though? Have people stopped playing chess because they could buy a $7 app that plays better than the best player in the world? No, they love chess. The question is why? Right? And then we answer that question, we'll see that's one scenario how AI goes. It just gets much better than us, but still we have a really important role because it's not really about the chess, it's about the humans and the human involvement in that process, which is important. So thinking about a narrative based around how chess changed the world, that's sort of important. We don't know whether that's true or not, but it's worth ways a possible scenario in the future. The second one, the steam engine. Steam engine developed late 18th century, didn't really have an impact for a number of decades. It was very important because just like AI, it's a general purpose thing that in essence replaces both human and animal muscle with this device. So very much like AI coming in, replacing human cognition in the same sort of way. And so under that scenario, AI, even though it could have a big impact now, and everyone sitting in this room could say, wow, it's going to be really important, it's going to change things, there'll be a delay of maybe a decade or two before it actually changes things. And the fundamental reason is inertia, but also the entire workflow of a task or entire workflow of research must be replaced, each element of it, before the actual workflow the changes in the workflow lead to a substantial change. Even though we can see how individual tasks can be completely done by these machines in very easy ways, that we don't actually see the benefits of it until it's actually matured to a large degree. Third one, MOOCs. People remember MOOCs, massive online. Anyone remember MOOCs? Well, MOOCs are going to change the university. It's going to disrupt the way things are done. No more teaching. We're all out of a job. Didn't happen, right? Now, I remember back now, I'm thinking, I'm out of a job, right? I'm thinking they're obviously going to be useful. The university's really in trouble. Harvard, MIT have formed a consortium, all this sort of stuff. We're really in trouble. Didn't happen at all. Why? Because humans had to interact with the MOOC, not an AI image of how a MOOC would work, but humans had to interact with it. And humans, when they went to the MOOCs, they didn't have that direct personal contact. It was really important for learning. So they all failed, and they rose very noisily, but failed very quietly. So we don't know but it's important to know that this is a possible scenario for AI. It's obviously very powerful and can obviously do many things, but maybe it won't. Maybe people will get sick of working with AI, so want to work with people. So yeah, it does stuff in the back room, but doesn't radically change our research world. So that's another one. And the last one I'll say is autonomous cars. I remember thinking in 2014, wow, autonomous cars, in 3 years I'll be driving around in a Waymo type device and everything will be fine. And here we are, we've got Waymo, but the world has not radically changed, because getting to 90% of an autonomous vehicle, you can do very quickly, but getting that last 10% is extremely challenging. So even though Google/Alphabet has spent literally a fortune since 2009 building this technology, it's still not quite there. And if we look at all the reasons it's been held back, looking at the technical reasons, but also the regulatory reasons and the fact that humans are very nervous about autonomous cars, we could see a parallel path for AI through that process. This takes a long time. So these are different ways of thinking about what our future is going to look like. All right, last one I just mentioned, and this is drawn from economics, an economic perspective on things. And as it says up here, the idea of scarcity still exists, but it's changed. So what AI will do is, in essence, come through and create abundance in certain areas, remove certain paths. And so, but what will happen is then scarcity will be created in other areas to compensate for that, and people will want things that are not easily available through AI. And it's likely possible, this is a scenario, keep in mind, that a lot of these things will involve human relations, things that AI can't provide and easily replace. They're not things we have now, they're created through the scarcity process or the abundance process, but it gives us a way where humans are still very much involved, and we as researchers are really valued for what we bring as humans because of the relational content of it. So this is, I think, an interesting possible scenario. All right, let's see. How will research evolve? This is essentially sort of looking into the future. I'll say a little, one is I've got up here the datification of disciplines. And I've seen this happen in my discipline as well. It's the notion that the actual core knowledge and core ideas of a discipline get written down or structured in a way that they can be read and modelled by AIs, and then much of the discipline is subsumed by the AI. For my discipline, that's largely true. All of the proofs, all of the knowledge, all of the mathematical structure of it, the AIs have already learned from. They haven't taken the very top end of it, but it's increasing very quickly. And what will happen is other disciplines, which are less rule-based, will slowly be eaten away as the knowledge within those disciplines it gets placed in a form that the AIs can understand, the so-called datification of them. So I think that's important. Other things, AIs reduce boundaries between disciplines. I think this is very important. Many of you have probably heard in the last couple of days about OpenAI announcing a proof of a very important theorem. People have heard of this? Yeah, last couple of days. But if you look into what they've actually done, the AI went and looked at a very, very broad array of mathematical disciplines, not necessarily in the combinatorial subset in which the problem was actually posed. And what it did was find other ways which are very disparate, very far away from that, standard methods, and applied them to solve this actual problem. So what it was able to do is not just draw from the subdiscipline that the problem was in, but a broad array of possible mathematical methods, known methods, if you will, and then apply an enormous amount of effort to find one that actually worked, found that it worked and solved the problem. So it has solved the problem, that's the important thing. But the way it did it was actually just looking at the span of existing knowledge across all the subdisciplines, rather than great insight in the subdiscipline that the problem was posed. So problems of that kind, which suffer from a so-called attention bottleneck, because no one's really applied the enormous attention to solve it, they will be solved very quickly by AI. Problem posed in that way that brings in new knowledge from disciplines that have not been brought to bear on demographic problems will lead to solutions of novel demographic problems here. A couple of other things, research titles become tighter. I won't need to explain that. Demography is, I think, particularly sensitive to this notion of AI coming in and making a lot of changes, especially demographic methods in a natural way, in the way that I've said. Perhaps I might expand on that. Scaling research by, that's the point I've just actually made about attention. All right, research right now for everybody in this room, including myself. I think it's about time that we start working with AI. Our role will be less to do with actually doing the work than managing the actual work and thinking about how to manage AI teams, individual AIs, groups of AIs, and then hybrid, where you have a working group of people, as we have now, and have AIs as a member of that group. They're assigned certain tasks and solve those tasks. But hybrid teams, I think right now, at least with the current technology, is a very important thing to actually do. So we'll need to lead teams. And for the faculty here, it's a lot like having graduate students where they do a lot of the work. You provide guidance and roles and mentorship. That will be true of everybody, including graduate students over time. They'll need to understand the discipline enough to be able to instruct an AI about what to do. It changes the emphasis from doing the work yourself as a process of learning to the process of being able to instruct an AI to do the work. And last one here, judgment being so much more important. It'll become much more emphasized that you need to have judgment about things rather than complete certain tasks. Right. Other ones, well, okay, I'm going to steal something from Terence Tao here, which he applied to math, but I think I'm just going to apply it to demography. Three stages of demographic research. Generation of interesting questions, it's very natural, it hasn't changed. Generating evidence, and then integrating, the last step here, integrating the outcome of that inquiry into the broader base of demographic knowledge. What do we learn from this specific fact that applies in a more general way? Now, the first one, AIs can help a lot with that because it can generate random hypotheses, and we can then, as part of human selection, human judgment, decide which ones are important. The second one, it's very open to AI doing. It does data analysis tasks, well-posed problem, and so on. We don't need to expand on this one. This one is still going to be a human endeavour as well. We really want to create demographic understanding by the studies we actually do. So the idea here is how we integrate the specific outcome of the study into broader frame is something we'll still need to do a lot of work on. Here. And these are just basically the points that I've just made. All right, just the last slide here, a couple of things about education. I've been thinking about this a lot, as I'm sure many of the faculty have. Education, I think, is going to radically change because of that. The AIs, if properly used, are extraordinarily good learning tools. If you want to learn something, you have a personalised tutor who's expert, who's always there, never gets angry if you ask a stupid question, and so on. This is clearly, as a tool, just fantastically useful for learning. So that's going to change things a lot. And so this aspect is really going to change the way we teach once it becomes integrated into the process overall. Another thing which is really important is just this assessment. Now we don't necessarily need to expand on this, but how do we decide what a PhD is? How do we decide what a paper is? How do we decide if someone's a good researcher? Well, I can write a paper in the weekend and be pretty good and probably get published in a peer-reviewed journal. A lot of people can do that. It won't be great, but it might meet some minimal bar. But I don't want to do that. I want to do something else. I want to actually make a contribution, not just be the first person to do something. So how we evaluate things is very important. And the last one, I haven't emphasised it here, is fairness and other issues related to that. They're pushed into the background, so I wanted to focus on these other issues that are clearly vitally important in this area. Also, okay, so that's all I have to say. I'll hand over to Ian, and I'll really look forward to a discussion because that's the point of this talk. Great, thank you.
Thank you.
Okay. Well, we can start there. So thanks everyone for being here, and thanks Mark for taking that very big overview view of things. I myself am going to be much more like grounded in concrete little things. So as a point of context, I was extremely skeptical of AI, and I didn't really want anything to do with it. And then this winter, I taught my large undergrad course, social data science. And they were using it in ways that were in some ways terrible. Like they could produce perfect homeworks and have no understanding at all. I discovered you could do this by going to ChatGPT and putting the link to my homework and saying, please do this homework for me. And it's perfect homework. I also found that they were using it in very helpful ways. So some students were actually doing the coding themselves and then asking for, how do I make this bar graph a different color? Here's my code. Can you change this to be a different color? Or they'll say, I'm confused about, some point. And I could actually see them doing this on their laptop because often they were not ashamed at all about the fact that they were doing this. And And so then I thought, wow, this is really powerful. I ought to be doing this more myself, or at least figuring out what to do. So I am just beginning my AI journey. This is like about February. I put my first prompt into ChatGPT. I've now sort of moved over to Claude. And I'm going to tell you about some things I ask AI to do that I feel confident that it can do well. So I have it search for papers, do math for me, check my code for errors, and check my paper for errors. Okay, I use it to search for papers. So the other day I was talking with a grad student and I was remembering there was this quote I wanted to tell her about that was about what would make a good causal treatment. And I remembered that Paul Rosenbaum had this quote and I thought it was in the book Observational Studies. So I prompted Claude, can you find the Paul Rosenbaum quote from Observational Studies about how given the choice, one would prefer a treatment that is short, abrupt, and of dramatic proportions, or something like that. I wasn't exactly sure how the quote went. And then it came right back. I can see that quote is in section 11.10, gave me the name of the section. This saved me so much time because I just went there and found the quote. The quote's at the bottom there. You see that it's actually not exactly what I recalled, but it was almost exactly what I had given it. So I was able to find this paper that I already knew really fast. I'll come back in a few slides to a more general use of finding it, searching for papers. Okay, I asked AI to do math for me. So I discovered this teaching the undergrads, that it is just really good at math. Math, like Mark was saying, like very rules-based, like AI tools that can read all the math textbooks and they just like do the math way better than we would do the math. So for context, I'm working on a project about this common research practice that my co-author and I think undermines parallel trends in lots of difference in difference studies. And we wanted to be sure that we had that right. So we had already done a few things. So we had already simulated our problem. We wrote our code ourselves in R because that was what we were comfortable doing. We had also proved in math that this could be a problem. I mean, like with pencil and paper, wrote out some math. But you know, when you do your math with pencil and paper, you like don't really know if you got it right. Like maybe some of you are better at math than I am, but I often think like, ooh, did I skip a step? Did I lose a term here? Do I really feel confident in that proof? And then we also had a solution, something that we thought was new, something that we think works, and we think we showed that it worked in math. But on all of this, but errors. Like we're proposing a thing that undermines, we think a lot of research using difference in difference has made this error, and we want to be really sure that we've done our approach right. And so here is what I handed to Claude. I said, this system of equations defines a data generating process for each unit I indexed by time periods t. And you see this is a bunch of LaTeX code for math that I had already written in my LaTeX file for the paper. And then I asked it, can you prove that the treated and untreated units have different expected values of this quantity, which is the parallel trends assumption written in math? And it was awesome. It said, here's the proof that parallel trends fails. And it started out, we want to show that. And I looked at that because it wasn't quite exactly what I'd written. But then I was like, yes, that is the proof, the thing it wants to show. And then it walked all the way through the proof. I don't have it on the slides, but there were parts where it used some math that was not familiar to me. And I could ask it, like, can you explain step 5? That part's confusing to me. This is like me getting the expert tutor that Mark was talking about, sort of helped me figure out how to do that proof. Okay, so then I got to the end of that and I was like, awesome, we have this cool idea. We now think the math is right. We think our simulation is right, but has someone else done this already? And so I asked it in the same chat thread, can you find if there exists an academic paper that shows the result you just derived above? And it found this Abadier 2005 paper, which probably is how it could do the proof so easily because it read the 2005 paper that I had not read. Upon further inspection, this paper is not exactly what we're doing, but it's very close, as often happens in papers. And so this was real helpful to me. And I'm now thinking about doing this a lot, where I will tell it, I'm thinking about writing this paper, like as much detail as possible about my paper. Can you find someone who's written that paper? And if they do, then, okay, someone's written the paper. And if it doesn't, maybe it can help me find the relevant papers. Okay, I asked AI to check my code for errors. So this example is a paper that Jenny and I just finished. Jenny doesn't know that I put it in the slides here. I knew that this happened. We wrote all our code by hand because I was AI skeptical. I think you were AI skeptical. Well, neither of us is writing our code with AI at this point, I think. And so we had finished our paper. It was conditionally accepted. And you know, when you get that last chance to the editor wanted us to fix a couple things. And then at that point, I take my replication code and I put it all in a zipped folder and I put it on Dataverse. And I thought, I have this zipped folder. I should hand that to Claude. And so I did that. I gave it code.zip and I said, can you check this code for errors? The main.r file calls the other files, which maybe it would figure that out for me, but I thought I might as well tell it how this structure works. And it goes, good, I have all the code. Let me now systematically check for bugs. And this was great. It took a couple minutes while I went through everything, and then it gave me a full report of what it found. And I have an example here. It discovered that I had written some code that started with a data set D, but I meant to start with the data set estimation. D was the global data set, estimation was the one I was handing to the function. And the way this was relevant was within our bootstrap calls, we needed to hand it estimation because estimation was the bootstrapped data set. So this was great. It told me, here's the line, this should be estimation. And at first I was like, oh no, this is right. And then I looked in the code and I was like, yes, that definitely should be estimation. And then I changed it and reran all of our code. And the confidence intervals are fine. Paper is still standard. If I hadn't asked it, I would have had this error in our code that would be really hard for us to catch. And it was just ooh, got that error in the code. Okay, I have also asked AI to check my paper for errors. So this is one I was less certain that it could do effectively. So this example is a paper with Soon-Hong Cho in political science. And we were submitting our paper and I just handed it the PDF and said, can you check this paper draft for errors? And it looked through it and it found little things. In some places we use the word non-existent with a hyphen and sometimes without a hyphen. Great, that's totally AI can catch that and would love to make it consistent throughout the paper. It found little things like typos, philosophical should be philosophical. I don't think I have this on the slides, but I asked it to check that my appendix references were correct. In the paper, when you say appendix B shows such and so, make sure that appendix B is really the one that shows that. That's tedious, but super fast now. And I believe is this all I have? Yes, that is all I have. So these are the 4 things that I have started asking AI to do. Obviously, I'm just at the beginning of this. So I know others who are working with AI tools to do their coding for them. And I'm actually not personally opposed to that. It makes me a little nervous. Sometimes when I ask it to code things, it comes back with very complicated code that I then want to rewrite myself, to make sure I understand everything. There are probably many more uses beyond these, but these are a few examples where my undergrads were doing these things. And then I was like, wow, that's a very tedious task and it can do it much more confidently than me. And that's what I got. So maybe now we go to Q&A.
Yeah.
And also if anyone else, if you all have ideas about what else we should be doing, there's probably people in the room who are doing way more than I am here. So leave it there.
Thank you. Let's open it up. Thoughts, questions for either of our speakers or just based on issues that came up? I don't know if it would.
Do you want us to go there?
Question maybe for Mark, for both of you, but I think it comes from Mark's presentation. Not sure I can formulate it well, but I take your point that judgment becomes more important than knowledge. But I feel like we're talking about our generation where we derive our judgment from the knowledge we got, which we couldn't get all the knowledge so we had to make hierarchy. This is more important than that. So our judgment, I think, came from the fact that we were trained on limited knowledge. And I'm thinking how moving forward, we're training students and we're telling them, okay, knowledge is not important. Don't forget about knowledge. You can have access to everything. How would they form their judgment about what is important and not in that context?
I completely agree, and that's exactly the conundrum here. So we brief answers. We have to change the way we teach to try to resolve that. And the natural way forward is, of course, you teach them some knowledge, enough knowledge that they build the intuition, which we really care about. Not that knowledge is unimportant, but knowledge is now covered by the AI in ways that weren't true before. So the natural path forward is to bring knowledge in, but knowledge itself is not the ultimate goal. It's the insight into the discipline of which knowledge enables, but it's not the essential element of. I think it's going to take us a long time to change our pedagogy and learning styles to do that, but I think it's the right goal.
Well, are you gonna call or do you want us to?
Oh,
Yeah, I was just thinking about or wanted to hear your thoughts about AI errors. So, a lot of what I end up asking it to do, it might generate things that it's very confident about that are false. And, even like simple tasks that I've asked it to do, like putting in references or something, sometimes it's like, whoa, it just really screwed that up, in a major way. And with no kind of signals that it might have been wrong. So, I've been trying to kind of like code it to alert me when it's not sure, like, did you actually look at this paper when you back to it, like some kind of check. But I was wondering just, your thoughts on how quickly this is, getting addressed, or how quickly you've seen it get better over maybe the last 6 months, and how this should be integrated into the process of using these tools.
Yeah, I'll answer first, maybe I'll comment. So there's a number of points. One is, it's an intrinsic part of the bottom-up design of these things. You can't say, don't make mistakes and errors and enforce it. It's an intrinsic part of it. It's very difficult for it to make. So in other words, it makes lots of errors. That's one. Definitely getting a lot better over time, because the commercial enterprises who are pushing the boundaries of the frontier models, they're clearly really aware that humans are not tolerant to those sort of errors. So even a low error rate is going to make it less likely that their AI is going to get adopted. So they are improving over time. And the third thing is, it then falls upon us humans to be very critical of everything that's said, and that our role then is to actually verify things. I think it'd be a terrible idea if ask it for references and just take those references as fact, because we know it's very, it's easy going to fabricate those. So ultimately, humans are responsible for what's written, and as a result, we'll have to take on that task. The last thing I'll say is that the natural thing to do is, instead of having one AI working for you, have a second one, and the second one criticizes the first. The second one's instructed that the first one's ridiculously fallible, makes stuff up, it's terrible. Watch out for it and tell me when it does something wrong. Then you add a third one that criticizes the second one. Actually, this isn't even a joke, unfortunately. It's a very natural way to actually try to reduce the magnitude of the problem.
So interesting. I think we definitely need a follow-up session where we see that in action. That's really interesting. Ed.
Question I wanted to raise was around replication. And something that we're seeing now is that these base models that you can use for free, or that any of our students can use for free, these are the ones that, less likely to be facing hallucinations now, but if anything it's going to be that, and not the pro models that any of us could pay for now. And so it seems to me like, Ian's use case around like having it debug code, you can go and look at that code and you can say, I agree with that judgment or I don't. But if you're having it replace certain human tasks, like, content coding of newspaper articles or something, there's a couple issues. One, you certainly want to have it on that pro account rather than the free version. But then these models are changing so fast, like the GPU, the 4.0 mini that was around last year, I think they retired that. So you couldn't even replicate something that was done a year ago. So I guess I want to see how you think about the sort of replication piece, and then the sort of gradations of models that are out there for research purposes.
It's a lot.
Sorry, that's too much.
I'll start. This is a serious problem. That's number one. That replication is obviously very important, and perhaps even becomes more important now. So one thing is to have archived versions of these models that could be used at some later point to replicate things. But I do think it's a really difficult problem. That would be the short answer. I don't know, Ian, if you wanted to add to that, or
I guess I just had another question maybe for you
Oh.
related. Does the coding seem like it goes in this judgment category a little bit? Like code these newspaper articles is a little bit of a human judgment thing, like Mark's thing of what's an important output or versus like doing the math is a very rules-based thing.
That's part of it. I mean, I think because you could go back to that R code and you can look at that 10 years down the road and say, I see what the computer did here and I also agree with it and it's functionally correct. But some of these other things get a little bit black box, and if you don't have the model still around to replicate it later, you might not be able to correctly. It's just a question, it's something I think maybe we all need to think about all that.
I had two quick things. One, I have the same question Ed does, and it came up in a project for us where we did human coding of open-ended text. And we think it required a lot of good judgment. And the question always comes up, well, why didn't you just have AI do it? And one problem is replicability, in part because of the rapidly changing code, but also you can't see what the code is deciding. And you can't tell what nuance it's picking up from other variables, say in the data set. So by looking at other people in the same family, we can tell that when someone says Tom did this, we know Tom's relationship to these other people, whereas I don't think AI would have access to that broad context. So I think that is a big issue where judgment does come in and where the technical challenges are difficult, in part because a lot of the public use data sets don't let you use them with AI. So that's, I endorse that question. But I have another question, and I came up in your talk, Mark, about AI as generating evidence. And I'd like to hear more about what evidence is, because AI can't generate the data. So in large major surveys, you can't make up respondents. And in some ways, the only way you can find things out about the social world is by talking to people. So can you say a little bit more about what you mean about generating evidence and what evidence is?
Yeah, what I meant that is in terms of you would work with the data you actually have, and then it would do the analyses. It would consider all analyses at a depth that perhaps a human wouldn't be able to do. So it can do the analysis for you with some guidance, of course, but can dramatically just improve those processes. That's one. There is a second thing that actually relates to what you're saying. It's extremely good at generating synthetic data. Mm-hmm. And the purpose of the synthetic data is not to act as if it's real data, but synthetic data is actually a statistic of the data you actually have. Mm-hmm. And so it's a device to, in essence, make better use of the data you have. So one really useful thing of AIs is to generate synthetic data to have a better understanding of the uncertainties involved in the process. In other words, it's sort of almost like a direct bootstrap process where you can bootstrap from the data you have in that synthetic way. That was my intent.
I'm going to just jump in on Judy's question here about the how you might have been able to use AI to do the coding of open-ended responses. I could see a role for a reliability check on you all and to test the robustness of your results. Like if AI does what you did, does it come up with something very different? And if it does, you could ask it the rules that it used, and it might be an opportunity for you to say, I don't like what those rules were. Or it might be, I hadn't thought of that. Maybe we should incorporate that into what we're doing. Just a thought.
Yeah, I see what you're saying. I mean, if we could get past the technical constraint that the data providers.
In your case. Right. Yes, no, that totally makes sense.
But yeah, I can see how that could be a, oops, you missed this kind of thing.
Yeah, just also if it's making its own rules, it's interesting. If you don't tell it what you did, how did it do it? In principle, maybe not in this task. see what the decisions it made were and see if there's anything, you may say that's ridiculous. My judgment says those decisions were not useful. But it might have come up with some things that you hadn't thought of that you might incorporate. It's just kind of an interesting, it's an opportunity. It's another way to use the reliability where it's actually checking you in some sense. And then it allows you to think about, why there may be differences between what you did and what it did.
Although in that case, we might want to tell it what rules we were using and then see if for the ambiguous cases, it makes a different decision.
Yeah, you certainly can.
Yeah,
I
thanks.
saw a hand back here. Yeah.
This question is for both of you, and it's kind of like a two-part question about the integration of like AI and teaching. Because on the one hand, like I would not call myself like a very confident coder. And a lot of this has to do with like using AI in concert with like checking your code. And so when I tell faculty that, they're like, oh, well, don't worry, AI can code for you. That's okay. Like you need to rest more on the judgment side of it. But to Patrick's point, I feel like I can't judge it and vet it until I am actually confident in the skill itself. So then thinking about how to integrate AI with teaching, it suddenly seems like professors have this burden of teaching more in the same amount of time. Like you're going to have to teach students these skills and then also the judgment skill on top of that. And what do you think what room is there to move certain things out of your curriculums now that maybe are old to maybe make space for that? And then on the flip side too, I think a lot of computer science innovations over the last couple decades have integrated into the social sciences through people who are autodidacts and are able to learn these skills on their own time. And not everyone works that way. And since AI is such a boost, like how do you see, like what do you think the burden is of professors to kind of really teach students like hands-on? Don't just tell them like, hey, go use ChatGPT in this way, but like guiding them how to use these skills, how to code, how to like walk alongside them. Because a lot of this is very technical and not all students are equipped to teach themselves that.
Okay, a couple of comments, and I think it emphasizes Patrick's point as well, which I completely agree with. But I would say if you wanted to learn yourself code, you can work with an AI tutor who's very personalized and would probably do at least as well as a professor or most professors in that sort of score. So I think there's a self-learning process here. I'd also say that we're going to have to work lots of these things out, but that is how this balance works, what comes out of the curriculum, what goes in. But I have a feeling that we'll learn a lot faster with these tools. And so that I don't think it's going to be a fundamental problem. But I would emphasize, again, the point is you should learn how to code. It's really important to learn how to code, not, have an AI do all the coding for you, because that's not going to work out well in the long run. So that means you've either got to learn it with the professor or learn it with the help of an AI. And I think the second one's very possible now.
Hi, thank you. This is very useful. I wonder if you could speak to two things. One is the understanding part and with the judgment you mentioned, and we have to be the human in the loop to sort of make judgments. And then and my colleagues have always this issue is that in my experience, my ability to judge and my skill sets around judgment improve as I do things, including mundane things. Some of the tasks that I'm now outsourcing to an AI. How would that affect my judgment moving forward if I keep losing my training ground, my training opportunities to actually get into the nitty-gritty of stuff? That's one thing. The other thing is, what shouldn't we be doing with AI? I ask this because we know AI is creating a lot of problems. So those of us who are editors, who have to manage research, publishing resources, we see the scaling of the downside of academia, of research publishing, that AI is actually making worse. So, what shouldn't we do with AI? I think we, as much as we talk about using AI in research, what shouldn't we be using AI for in research?
I'll start maybe. So I think one important thing is we have to maintain those skills. That is, we can't let the skills atrophy for lack of use or to outsource them to an AI. we still need to keep those skills at a level, but I think it's not at the level we have to do all of the work. So we just like normal training have to make sure we keep our skill level by keeping our hand in doing things. I think that's just a skill we're going to have to learn, basically. On the AI and the peer and the editorship, taking a step back, I'd say AI is going to dramatically improve the quality of research. That's number one. The quality of research done by demography will dramatically increase because of this tool. That's one. But it creates great challenges for the assessment of research, like the assessment of a peer-reviewed paper. The natural sort of boundary for me is that I think of AI as, in essence, producing knowledge in the span of the latent space that it fits the actual world. So it's like the known facts. So any paper that's submitted to a review should be run through an AI and said, is this known facts? And if the answer is yes, it's not adding anything because it's still within the span of knowledge. As a result, it's not publishable. So we should use the standard, have AI assess papers, and if AI says this is known, then it's not publishable. We should only publish things that are outside the span of current knowledge. But I think it creates enormous challenges for the traditional ways we have of assessing research and peer review and coming up for tenure, and all of those things are going to radically change because of this. But we just have to adapt. I don't think there's any other choice.
Is that a follow-up? Just a quick one. I guess I would be a little more cautious about that because I think it goes back to the replication point. Sometimes replication should be published because that is how knowledge accumulates. And it's how you know that it's not a one-off if one person found it in one data source or in one setting. So I think that's a place where judgment matters.
Certainly replications are vitally important because if you have replication, it's because the fact itself isn't actually known.
Right. But AI might not know that.
Yeah.
So what I hear is kind of a nascent culture developing on what we should all understand about using AI. And one of the most interesting things in the discussion, to me anyway, was the idea that the potential that AI is going to transcend subdivisions within fields, between fields, and so forth. And I wonder, in developing a culture about that, is there the way you ask the question, for example, Ian's question was for me very technical. And it seemed to me to direct AI to a helpful response, but one that wouldn't necessarily lead AI to find in another field of study something similar going on. So, the sophistry problem in higher education that, we generate questions within subfields that other fields have already. If I ask in sociology a question about counterfactuals, it might not lead me to opportunity cost literature in economics. And so maybe we should develop a culture about the kind of ordering of our questions to AI, that we start in some sense a more general way, and then if we don't get what we want, then we go technical and specific. Because a technical question is likely to key AI to look to the journals you're likely to publish in and what the vocabularies and the literatures they're already in, and not to, I don't know if this, I'm confident about this, but I wonder if it's worth thinking about how to develop kind of culture across disciplines, but start more generally to maximize this potential of AI bridging what have been separate field.
I think,
I just have a small comment on that, is that I initially asked it to find examples where parallel trends failed or where, like, sort of a more general version of the question. And it just pointed me to the most cited econ papers, like econometrics papers, which I had already read and restated. It said, oh, this is already known, see Callaway and Santana, such and so, theorem 3.2. And I actually didn't get a useful answer out of it until I gave it like very specific details.
Could you have asked it about a historically situated phenomenon, some variation or change or problem in the world, and see what it came up with before you got into the technical language?
Yes, I don't know for sure. I would imagine how to make the prompt precise will differ across the kind of fields we're all in. And for me, the precise thing was the math, but maybe it would be different in other settings. You had something.
Oh, I think AI should be able to pull knowledge from different disciplines because it's less bound as we humans are to those disciplines. And because it represents sort of latent structure, underlying structure of things, the structure in the subdisciplines will be the same. If the words are different and that some of the facts are different, it's much more tolerant to that because it's representing the underlying structure of the argument rather than many specific facts about that argument as well. So it should much more naturally be able to pull from econ or even further way and bridge those disciplinary boundaries.
I just wanted to make a point about what Mark mentioned at the beginning of his presentation along the lines of AI being really good at things that are very well structured. I think we can take advantage of that structure of the systems going along the lines of what you were describing for tasks that involve like text. Well, I actually done it, and what I did is taking advantage of that structure, I created a rubric. So in the rubric, I give as much detail as I can to each of the items that are important to me, and I assign even a number that is, here is the maximum code I want you to give me, the smallest you want you to give me. And then I instruct the AI to read the rubric. And then I create an agent, as Mark was saying. This agent only does read the document and sends the rubric and goes question by question, reading my rubric, giving a score, and then comes the second agent and makes sure there is a number associated with it. And there is also a field that tells me what was the reasoning, why that particular score was given the rubric that was provided. So now I get as an output a file that has the actual score and a reasoning why that score was given because of the rubric that was used. So this is what I mean by it's not completely like a replication process, but allow us to replicate as much as possible because now I have a rubric from which these are the rules that are going to be used, and I enforce the machine to go question by question, feeding that into the system and giving something back and justifying that answer item by item. And it actually did very well. It does actually extremely well, even when the answers are relatively general. Because what I did actually tried in some of my past classes that I have graded already exams that I graded based just on text. So I inputted that with my rubric. And when I got back, I basically got similar score that I actually provided when I did it. But now I have a reasoning behind why that score was assigned to each of those questions. So these are, I think, very useful. Again, transform whatever problem we have into something that is fairly structured. And I think we have an advantage of using the system.
Yeah, those are really good points. Interesting.
Yeah, Mark, you said something about the quality of research is going to improve. I'm sure that's quite the possibility is there. At the moment, it's not happening because of the slop we're getting out of.
Yeah.
People are misusing it. It tends to scale the worst parts of what we are. But take it to the other extreme. We get so good at, our judgment. That's our thing. And the AI is getting good at these things because it's learning from us. They're scraping us and they're learning these things. At what point do we get to in this hybrid AI researcher thing where we say, why am I sending my papers to your journal? Why can't I send it to Anthropic or OpenAI as inputs into the AI? If I have ideas that are truly novel, Claude doesn't have anything, why are you sending it to a journal? Why don't you submit it to Anthropic and, it becomes part of the AI? Pretty soon you will be writing for the AI. Is that far-fetched?
There's a lot to unpack about that. By sending it to Anthropic, in essence, the key idea is to make it part of the model in a very direct way rather than create a separate information. I think there's a lot of merit to that. I'll give a sort of parallel example. I was thinking of writing another book, and I thought, well, that'd be a good idea. I'd enjoy doing that. And then I realized, well, maybe instead of that, I should build a chatbot and I should train the chatbot with my knowledge and get it to read the notes of the book, but have all the information in it. And a student can just have it, a discussion with a chatbot. It can produce text if needs be on topics. That would be a much better human interface for that knowledge than an actual book, which we know has lots of merit, but this might actually be a much better form for most people being able to learn. So I think it's a similar notion to what you're saying. You're taking that information and not necessarily putting it only in paper form, just placing it within the broader knowledge. I think there's some merit to that. It raises all these secondary questions about how do we assess what you've done and other components like that. What is the research contribution of your work? But I think these things become much more credible and feasible. They actually do.
That sounded dark. I don't know.
Concern with it, I can see the benefit of a chat box, but as someone who has TA'd a master's level class and really tried to mentor and support students in reading a paper, I think that it's really concerning that, like, not to be blunt, but like people will forget how to read or like read critically, because I think it's a big concern of like reading a paper and trying to figure out what the objective was, what's the actual problem they're trying to solve. And I think students are really not able to do that.
Yeah. I think that's true. I mean, my argument would be is that the chatbot wouldn't just tell them the answer. The chatbot would act as a tutor and would essentially say, well, why don't you read this, think about it, and tell me what you think is in the document. That's the chatbot speaking. So we could have the chatbot take that tutorial role, not necessarily just be the provider of information. But it's only a partial answer, I think.
Yeah.
Thank you so much for your talks. I am thinking a lot about where the norms are coming from. Ian gave the example of the students aren't even ashamed. And so I think norms are evolving differently in different subsectors of our society. That will also happen globally. But, is it the university saying these are rules for AI for students? Is it the department level? Is it on the instructor's syllabus? Is it how the TA enforces it? Is it peers? As grad students, if we see our peers generate their field exams using AI, do we censor them? I think I'm concerned because I see even with research, these two presentations with Mark talking about how we might generate the initial idea, but then we're there to verify at the end and incorporate it into the larger body of knowledge. That's incredibly different from Ian's use of we are producing the knowledge, the analysis, the writing, and at various stages, we might have AI verify us. And so I think that how the norms around what's appropriate and what's good use of AI, what's bad use of AI, where those are coming from is, I guess, something to be interested in, but also maybe something to be concerned about. I know people who use it very differently, and the way we judge each other will inform how we then use it. There's a MIT study on AI in social science by Nate Wilmerth, I believe, and I am a participant in this study, and that's also shaped the way that I think about it in an interesting way. So I guess this is just bringing up ideas, but who do you think is or should be, the source of the norms that we abide by socially?
Yeah, I mean, there's a lot of good questions there. I'll answer with sort of an example of what myself. So what I've done in class, I'm teaching a class now. So I start a class, first thing I say to students is, you're here to learn, I'm here to help you learn. If you don't learn by using AI, just use AI to answer the questions, you're not going to learn. That's a waste of your time. It's your responsibility to learn. And so I say you can use AI in any way you want, but keep in mind, getting the AI to answer the questions is not going to help you actually learn. So you have to work it out for yourself along those lines. But I also use AI in the class in the sense of we give them a homework, and I say, work on this yourself without an AI, or you can use an AI to help you, that's perfectly fine, but focus on the learning goals. But if you submit anything for the homework, I'll give you 100% for it. And then anything they submit, I then, working with a firm in town that essentially provides feedback, AI level feedback. So take whatever they submit, the AI provides detailed feedback in every sub-question, including a numerical grade, but it's mainly a 2-page or something feedback to every student on their homework. So if they do it by hand, they know they're going to get detailed responses to what they've actually done as a learning device. And so I think that the idea there is we'll have to reconfigure the way we teach and the way the students think about these goals. I don't think we can just tweak what we have now, the norms we have now. They'll need to be rethought in these much broader ways.
Yeah, I've been hesitating adding this in because I didn't think this is a question necessarily, but I've been thinking about this a lot because I have an 11-year-old who probably like many of your kids is like, 16 or 17-year-olds at math, but like 7 emotionally, right? And so, he's taking this hyper accelerated math class and all of the kids are just submitting, they just go home and do a chat GPT. So they don't do it in the classroom. They go home and their parents encourage them to do this. And I can see this on all of our chat groups or whatever. So he loves math. So he's devastated by this. But I was like, okay, fine, you're learning math. They're not. Their state assessment tests are going to be terrible. Who cares? Whatever. But he's deeply concerned because the teachers stopped teaching math in the classroom because the kids don't pay attention because this is 11, right? So these are our students. And the one thing I wanted to mention is we talked a little bit about online, or whatever, our Canvas or whatever. So I can see on the submission consoles, it's something similar to Canvas. And the teachers have it set that if they submit it, they get 100. And they used to have an in-class test component that was like half of their grade, but now in response to pressure from parents, the inline in-class test, which they all get D's on, is like 20% of their grade because they're working really hard and they're doing all of their stuff and getting it, but it's all chat GPT submitted. So I just wanted to caution that this is like what's coming up. And I've really started thinking about it in terms of like, I teach an online stats course for one of our master's classes. The template was kind of handed to me by our program of how we do assessment for these, and it is all online submissions, right? And I can look at it now and see that most of them complete this in like 8 minutes, which should take them a couple of hours and submit it. But the way it's set up is so like the assessment and judgment thing is on us, right? The distinction between assessment and judgment or the marriage of assessment and judgment. But also you think about kids are thinking, I'm really great at math and my teacher's just mean, right? So anyways.
I think these are good points on both of this. I'd say clearly assessment, you have to really completely do it.
Yeah.
Ultimately, students are here to learn and they have to recognize, well, obviously they're cheating themselves by doing this process, which is sort of sad, but I think there's a lot of responsibility there.
Yeah. But if the overall culture is changing so that the goal is to submit this and get the grade and move on to the next. Yeah.
Again, I don't want to say it's a question because it's more of a comment, but we made a comment in class. It's master students, professional program, where we asked them to please do the reading, even if it takes asking AI for help.
Yeah.
And half of the class was offended that we made this suggestion because they brought up the fact that they feel that they're going to not have a job after graduation because AI is taking away this, entry or level jobs that somebody with, basic data analysis could be taking on. And then I also read this morning some briefing about the anti-tech extremism as being a new term that has been added by the Department of Justice as a kind of terrorism that there's going to be monitored. And I'm just saying these things to maybe like play some of these fears that there are around the use of AI in the classroom or by our students is that, as researchers, I personally love using AI to help me, merge census data with like other kinds of spatial data that I have. It takes me not 7 days, but maybe like 17 minutes. But I also see that the students that we're, teaching are then going to a job market and to a society that is seeing this as an existential threat. So I think there's maybe some balance between how do we use it effectively as educators and researchers, but then also how do we assess it in the changing landscape where tech is not just like a part of our lives, but, a deciding factor in how potentially the economy is moving forward. So some thoughts about what I've seen this quarter.
So many interesting points that have come up. We do need to wrap up in just a minute here, but I also wanted to say that I really appreciated some of the comments around the ethics on the what's possible and what's concerning and what should the norms be, and the comment about should we just be submitting our most novel work to AI. So with AI, it feels like the accountability for the information and how do we know is less transparent. If you're reading an article, you have evidence. You can look at the evidence on which the argument is based. And so that's something that seems very different. I'm thinking about Mark's comment in the very beginning too, about how the technology, we as human beings may still bring something to the table in our humanness. And the example of MOOCs is really good. I'm also thinking about Zoom, where Zoom really could have transformed the way we communicate, and it has. But there still is something about human interaction that we're not getting from Zoom. And yes, these chatbots, there's all this stuff about people using them as their therapists, as their romantic partners, as everything. But Zoom exists, but we still like to get together and interact, and we still feel like there's something different that we get from that. So I thought that was a really interesting point. And then these comments about shortcutting our learning by not actually working through the problems. I also just think about our research, and I think about Ian's example of finding the quote, which sometimes you just need to find the quote, and that's incredibly helpful. But other times you need to find the quote. So you go back to the book where you thought the quote was, and you start looking for it, and you find other things. And there's something that's maybe lost in the hyper directness of AI. If you can just go get the answer to the question that you asked directly with no side paths, no tangents, yes, maybe it's more efficient, but there seems like there potentially is something very major lost there about the way creative ideas can come about in research. So there's so much to think about here. We are at time, so I'll stop us. Thank you so much to both of our